All right, we are now covering today 5.3, which is on function notation. This is chunked into two separate sections, 1 to 3, and then 4 to 7. Let's take a look. They gave us two math tips to start. It's important to recognize that the f of x does not mean f multiplied by x. And notice that f parentheses x equals y. For a domain value x, the associated range value is f parentheses x. Now, it says, when referring to the function in item 8 in lesson 5.2, it can be confusing to distinguish among all of them since each begins with y equals. Function notation can be used to help distinguish among different functions. For instance, the function y equals 9 minus 4x in item 8a can be written as follows. F parentheses of x equals 9 minus 4x. I want to highlight some important information here. This right here is recited as f of x, and it means equal to y. Okay? Next thing I want to note, importance right here. F is the name of the function. X is my input variable that comes from there. Okay? So f is the name of the function. You can call it p of x. You can call it c of x or q of x. Heck, we don't even have to use an x. We could actually call it n if we wanted. We could say f of n. But just recognize that the number that, or the letter that's inside is your input value, and the letter that's on the outside of the parentheses is the name of your function. And remember that this is the same thing as saying y equals. Okay? So let's make a note of question number 1, and I will work through these with you. Number 1 states, to distinguish among different functions, it is possible to use different names. Use the name h to write the function from item 8b using function notation. And I'm going to pull over 8b. 8b said, I'm going to write this over here, y equals 1 over x. So it wants us to name this h. So we are going to say h is the name. My variable is x, my input. So I'm going to put h of x equals whatever that was, 1 over x. All this is doing is replacing my y. All that's doing is replacing y. Okay? Function notation is useful for evaluating functions for multiple input values. To evaluate f of x equals 9 minus 4x for x equals 2, you substitute 2 for the variable x and write f of 2 equals 9 minus 4 times 2. Simplifying the expression yields that f of 2 equals 1. Number 2. Use function notation to evaluate f of x equals 9 minus 4x for the values of x equals 5, x equals negative 3, and x equals 0.5. So what we're going to do here is we are going to do f of 5 is where we start. So we say f of 5 equals 9 minus 4 times 5. Well, 9 minus 4 times 5. Well, 4 times 5 is 20. 9 minus 20 is going to be negative 11. So we would have the statement f of 5 equals negative 11. Input, output. Okay, and let's talk about f of negative 3. f of negative 3 would be 9 minus 4 times negative 3. Well, negative 4 times negative 3 is positive 12. So 9 plus 12 is going to give me 21. So we would write this as f of negative 3 equals 21. The last one that it asked me is f of 0.5. Well, 9 minus 4 times 0.5. Half of 4 is 2, so 9 minus 2 is 7. So this would say f of 0.5 equals 7. On to the top of the next page for number 3. Number 3 says, use the values for x and f of x from item 2 to display the values using each representation. A list of ordered pairs. Okay, well my ordered pairs would be 5, negative 11, input, output. Negative 3, 21, input, output. And the last one is going to be 0.5, 7. And remember, this goes in a set notation, okay? Table of values, remember that's just my, here in this case it's going to be x and f of x, where x is my input, 5, gives me an output of negative 11. Negative 3 gives me an output of 21. And 0.5 gives me an output of 7. Next to the mapping, remember the mapping has those arrows involved. So we're going to say 5 goes to negative 11. Remember, I draw that arrow. We've got negative 3 goes to 21. And lastly, we have 0.5 going to 7. And in the final one, it asks us to graph and we're going to have this other one is going to be like way up here, okay? It's like way over here somewhere. Kind of, what should happen is these should all fall kind of along the same line. On to your debriefing question.